we are back on the SD40-2 project, USA Trains, putting in the RailPro system. So, as you know, we had some issues getting the shell off. Screw flipped around, head down into the bore, and got stuck. And it was a half hour to get that done, and I, because of my frustration, forgot to show the rest of the disassembly. Well, anyway, and then I will summarize that. Anyway, the very first thing I'm going to do is this weight right here was the weight that was included with the engine, and I believe it goes here. Okay, that's the original location for it. Well, I still want to use that weight, but I know that I'm going to put my battery back here. I'm going to put the RailPro receiver here, and I'm still going to maintain this front weight. So what I'm going to do, take this weight off. I'm actually going to machine these legs off so that it sits right here. Okay, and I'm going to need to make sure this is nice. It's got a little slot for an opening for the speaker hole. This is going to work out pretty well. So let's go ahead and do that first, and then I'll show you the next step of what we're going to do. So we're going to end up taking 340 thousandths off the top of these, or the height of these tabs. I should actually check. 340. Let's see if we'll miss the vise. No, we'll have to space it. I'm recording. What?
It's on.
Okay. Thank
It's
you,
on
babe.
now and it's on at 6. And
Okay, babe. Thank you, babe. Well, that material is pretty sticky, but no problem, we get it done. That's what we wanted. Machine those legs down. that'll be helpful. Let's get these parallels out of here. I'll get those cleaned up later. Get those put away. Anyway, there's our weight. Let's go put it in the engine. At least test fit it. See how that goes. Alright. Here we go. Nice. Nice. Alright, so the next thing I've got to do is, well, here's the 3D printed mount for the LM4S, for the GP38. It doesn't look like it's going to work here. So I'm going to redesign that. This is the height that the items would, the receiver would sit in there. So I have to design this to fit over this so I can maintain that weight. This will hold the weight in place, essentially. And then actually allow my wires and stuff to pass from the front to the back while the LM sits here. But I still want to be able to get to wires and get things routed. So let's go ahead and crank open a design program and get that part designed. And then we also have to redesign, this is also the battery mount for the GP38. Well, it doesn't work here. I'm going to end up putting the battery right here, okay, in the back. On the GP38 there's enough room between these posts to fit the battery, but not in this engine, so it's going to have to go here. So we're going to design a 3D printed mount for that. Now I think it's going to be best if they're separate components, just like they are here, the LM mount and the battery mount. So I think I'm still going to go with that, but this device is actually designed to be bolted in to the bottom of the chassis. So we're going to work with that, and on the last engine, the GP38, the screws were underneath the fuel tank. Worked a charm. So anyway, we're going to try to capture this weight with this 3D printed mount, or a 3D printed mount. We're going to redesign this so it sits here, clears everything, everything's wonderful. Velcro goes through here to strap the battery in place. This has to sit down in there and clear everything. This post might, well, we'll have to see. That post might have to be machined out of there. I don't know. We'll see. Alright, here we go. Well, again, here's the old Rail Pro mount for the GP38. Got to redesign it for the SD40-2. We want to fit the weight underneath it. And here you can see the unit that I have now, right? So we're going to go ahead and we're going to make some changes to this. So I'll do a save as, and we'll bring this in and we'll make the changes necessary. So hang tight. Let me just get started on this and I'll try to show you some of it. So the first thing I needed to do was to narrow this. This is 1.4 inches. It needs to be 1.25 inches wide to fit the between the posts. We've got to get it, we're going to get it to fit between the posts here. It's going to actually extend beyond the posts a little bit so I can screw it in and attach it. So hang on, let's get back over here. So we've narrowed it to 1.25 inches. Let me see here. Now we're going to go ahead and we've got to get this to go over the top of this part. So I'm going to get some measurements. Let's take a look. Let's take a look.
This isn't some trick, Mr. Trini. This isn't a show.
4.4 would get us pretty good. Edit.
Touch. How you did it, and he's gonna prove it, aren't you? Aren't you?
Well, if you're gonna catch me anyway, I suppose I may as well just confess.
What? What do you mean?
In fact,
I'm going to take this and suppress that feature. There we go. You can see we've actually got walls that are way too thin here now, but what we do have is we do have enough length to fit this component along its length. Okay. Now we need height, and actually the maximum height is going to be this. Let me go ahead and measure that. I'll get back to you. Hang tight. Alright, well, we managed to get this, the one side, increased in thickness, right? And that's going to be the thickness that requires us to stabilize that. And actually, again, this is a little bit longer than the GP38 one. This is actually going to be SD40-2 receiver mount. Okay? What we're going to do is we're going to actually get this done and save it as an STL, and we're going to 3D print it. We're going to print it out of ABS. I print very few things out of PLA, especially when it comes to my trains. So let's go ahead. What we're going to do is this feature, this thickening feature, we're going to go ahead and we're going to create a linear pattern. We're actually going to mirror that, so that the mirrored face is going to be this. I'm sorry, the mirrored face is going to be our right plane, and the mirrored feature is going to be this item. So let's do that. There we go. There's our part. It's a little narrower than the old one. It's okay. The reason for the bridge here is so that I can easily pass wires through there. Anyway, the next thing I've got to do is put some screw feet on the bottom. There's some bosses. They're actually down here. I'm going to go ahead and drag those to the bottom of the let's see if we can unsuppress those. Yeah, I'm going to have to recreate those features. There's going to be some holes in the bottom here that I'm going to allow me to screw this item to the bottom of the chassis. Hang on while I do that. That's a little more advanced. So as you can see, here are the two holes, screw holes, for the attachment screws for this. So you're probably thinking, well, why are they square? Well, I do a lot of 3D printing. Actually, I do a lot of it for my day-to-day job as well. And what I've found is that in the world of 3D printing, when you have a circle item, all of the paths with the extruder, that what it touches off on this feature become tangential to that diameter. Well, when you have a square, and it's basically sized for, this will be for number 4 plastite screw, you have a moment of leverage. You have a square boss with these 45-degree pieces of wall touching against this. So mechanically, you get a mechanical advantage. If this was a circular boss, the boss would have more opportunity to spin or break off and spin because there's no mechanical advantage. I don't know if that makes any sense, but maybe I can show you that when we start preparing the 3D file. So the next thing I've got to do, like we did last time, I'm going to mirror these screw features. They're actually an inch apart from each other. I'm going to go ahead and I'm going to mirror those items too. We're going to mirror from this right plane these cut features. Oops, right here. Okay, you can see them. They show in a viewer. I'm going to go ahead and hit that. So there's our part, all redesigned for the SD40-2. I'm going to leave it right like this. I'm not going to put a lot of radiuses and fillets and any of that kind of stuff in here. 3D printing, it really hates that. It does it, but at least FDM printing. So I'm going to go ahead and I'm going to save this as an STL, and then we'll put it in a slicing program. I'll show you that. Alright, so this is the old one, or I should say for the GP38. And then this will be what the new one looks like. You can see this is actually the orientation you're looking at. I've got to clear that boss. We're going to try to clear that. So we'll just leave some room there. And the wires that go down to the truck, they're going to be passing through this area. So I've given some room there. And then this is where the Velcro will pass up through underneath there to hold the battery in place. So in general, this item actually, I'll glue it to the bottom of to the chassis. So anyway, let's go ahead. We'll get those two items wrapped up into the two new items we've created, wrapped up into a slicer program, Cura for me, and let's go ahead and do that. Hang tight. Well, here are the items into the slicer program. I'll put both of them in there and center them basically on the build plate. So I have a profile that I created called, I believe it's called ABS Bag Machine. And what I do is on my CR10 V3, I put a plastic bag over the machine when I'm making ABS parts just to keep the temperature in the chamber, and it works swimmingly. I mean, I've seen guys make giant insulated chambers, and I'm telling you, just put a lightweight bag over the machine. We'll show you that later. But anyway, let's go ahead. I've got these two items in here. I've got my correct profile created. I'm going to go ahead and slice this. It's going to take a while. ABS takes a while to print. 10 hours, 25 minutes. I'm going to go ahead and save that right to my documents folder right here. We're going to, the name for this is going to be, we'll just call it SD40-2 mount set. Mount. So, okay, let's go ahead and get this done. I'm going to go ahead and hit save. We'll go ahead and get this on a flash drive and get it over to the machine. Hang on, we'll show you that. Then we're going to wrap up this video, and after it's printed, we'll show you that.